G'day, welcome to your lecture on big data. In the previous lecture, I explained how AI relies on data, big data, terabytes of data, zettabytes of data. Ivana Bartoletti argues that the power underpinning AI is big data. Data in its current form and scale constitutes a new form of capital, and its extraction and exploitation lie at the heart of the rise of AI. After all, data is who we are, what constitutes our intimate being. It is our every online purchase, decision, opinion, every click of our keyboard, and increasingly every movement and sound we make in front of our computer is being turned into a commodity because of the value that this data represents to AI. Datification refers to the rendering of the social and natural world of education and learning, of day-to-day life, of shopping interactions, marketing, every aspect of life into machine-readable format. Datification is integrally connected to AI because it is this datification that makes AI possible. And it is AI and the fantasies big tech about what AI might be able to do that are driving more and more datification of more aspects of our lives. The world's data volume has increased dramatically in the past 20 years for several interlocking reasons. According to Moore's law, digital storage becomes larger, cheaper, and faster with every successive year. And with the advent of cloud databases, previous hard limits on storage size essentially became obsolete. In the early 2000s, companies such as Google and later Facebook harnessed cloud infrastructure to collect massive amounts of data for customer targeting for advertisements. Companies around the world soon adopted similar big data tactics, and as billions of new users gained access to the internet, data generation increased exponentially. The consequence of this increasing reliance on data will be a never-ending expansion in the size of the global data sphere. The amount of data that is stored in some form in the world. Estimated to be as high as over 60 zettabytes this year, the International Data Corporation forecasts that the global data sphere will grow to 175 zettabytes by 2025. To give you a sense of how much that is, a zettabyte is 2 to the 70th power bytes, or 1 sextillion bytes. This is the equivalent to 660 billion Blu-ray discs. It is an enormous amount of data with great ecological and environmental costs. But what makes big data big isn't just the volume of it, but it's the way that it renders into data many of the aspects of the world that have never been quantified before. Some of the characteristics of big data are defined by Rob Kitchen as being huge in volume, in that it consists of terabytes, petabytes, zettabytes of data. It's high in velocity, in that it's created in near or real time. It's diverse in variety, being structured and unstructured in nature. It is exhaustive in scope, striving to capture the entire population or the entire system in a frameless way. It has a fine-grained resolution and uniquely indexical identification. Big data is relational in nature, containing common fields that enable the conjoining of different data sets. And thus, big data is flexible, holding the trait of extensionality, where you can add new fields easily, and scalable. It can expand in size rapidly. Big data marks a transformation in how society processes information. The required reading is going to challenge you to start thinking about how big data has changed the way that we think about the world and knowledge. So what are some of the consequences of all this measuring? A really useful concept here is David Beer's concept of metric power, that datification sets limits on what is known and knowable, which influences how people and institutions behave. Big data has meant that the scale of metrics in everyday life has been amplified. Although it can be useful to think of this in terms of surveillance, the impact of this datification is not just limited to the art of watching, nor can it be simply reduced to the internalization of the feeling that we are being watched. It is also important to think about how all of this datification is changing the way that society operates. David Beer argues that metrics play an ordering role in the social world. In an increasingly performance-oriented society, metrics matter because what we measure affects what we do. We are created and recreated by metrics. We live through them, with them, and within them. Metrics facilitate the making and remaking of judgments about us. The judgments we make of ourselves, and the consequences of those judgments as they are felt and experienced in our lives. A simple example might be the metric power of unit of study surveys. As an academic, half of my time is spent researching and half of my time is spent teaching. Nobody comes in and evaluates my teaching qualitatively. Nobody's logging in and checking on my Canvas sites. My teaching is only really evaluated in one way: the unit of study surveys we ask you to fill out at the end of semester. And they also check to make sure I'm not giving out too many HDs. So my teaching is metricized by this unit of study survey, and the all-important, overall, I was satisfied with the quality of teaching by the teachers. David Beer has three conceptual frames to think about metric power: measurement, circulation, and possibility. What is measured isn't how much you learn, just how satisfied you are when you complete the unit of study survey. This is what is measured. This measurement then circulates through the university. It compared against every other unit of study survey and against the scores that same unit got in previous years. This then shapes the possibilities for how I am treated. I might get a commendation for having a unit in the top 10% of unit of study scores. This might influence my ability to get promoted, or if I was a casual or contract lecturer, it might influence my chances of getting employment in the future. But this will then go on to have implications for how I teach, as I come to teach in a way that adapts to this measurement. This is metric power. I might give inflated marks on all of the assignments you get back before the unit of study survey, and then mark really harshly on the final assignment, so I'm not viewed as being too generous. I might avoid topics that are controversial, that could see a student upset with me, or I might reduce the scope of the unit so you don't feel too overwhelmed. I might not put in as much effort for a guest lecture, because the score for that unit doesn't affect me in the same way as a score for my own units. Or I might not make time to speak with a student about their ideas, because what does one student matter in a big class with 400 students? Or I might follow the advice of this study that showed that giving students cookies increased the student evaluation score significantly. My teaching adapts to the metric power of the unit of study survey, because what is measured and what isn't measured matters. This of course doesn't even take into consideration the biases that are inherent in unit of study surveys, which are proven to be sexist, racist, and discriminatory. In one study, students interacted with two tutors, one man and one woman. At the end of the course, the female instructor had a lower score, except the course was online, and both tutors were actually the same person. As a young, white, straight guy teaching subjects mostly about video games, I think it would actually be quite tricky for me to get a bad overall satisfaction scores. What is measured matters. Anyway, if you take away anything from this, what I'm saying is please give everybody 5 out of 5, please. So David Beer argues that it is important to understand all of this in the context of neoliberalism and neoliberalization. So neoliberalism is contemporarily used to refer to the market-oriented reform policies commonly associated with the economic policies introduced by folks like Margaret Thatcher and Ronald Reagan in the 1980s. Stuart Hall explains that in general terms, neoliberalism borrows and appropriates extensively from classical liberal ideas, but each is given a further market inflection and conceptual revamp. The notion of the market, Hall points out, is central to understanding the move from liberalism to neoliberalism. According to Jody Dean, neoliberalism is the reformatting of social and political life in terms of its ideal competition within markets. Peck and Tickle similarly observe that neoliberalism can be thought of as promoting an almost religious commitment to the extension of markets and the logic of competitiveness. Neoliberalism isn't just marketization. Rather, the neoliberal rationality disseminates the model of the market to all domains and activities. This means that even where money may not directly be involved, you can still have the model of the market in action. We can instantly see how metrics might have a key role to play in affording such a set of impulses and developments. Put simply, competition and markets require metrics. Measurement is needed for the differentiations required by competition. We can then see the potential importance of the data assemblage and the infrastructures and systems of measurement to neoliberalization. David Beer concludes that systems of measurement and data extraction might be seen as the means of neoliberalization. Right? To stay with the example of higher education, Ben Williamson argues that the datification of higher education is integrally part of the ongoing marketization of the sector into a market in which institutions, staff, and students are all positioned competitively, with measurement techniques required to assess, compare, and rank their various performances. Thinking here of things like citation metrics, H indexes, and university rankings. But to jump back to our previous example of the unit of study survey, we see how by reducing teaching into a single score allows for competition between things that maybe shouldn't be compared, right? My undergraduate unit on video games probably shouldn't be compared to the 1,000 student introduction to statistics, which is always going to get bad scores because who likes statistics? In this way, neoliberal metric power changes the way that higher education operates, quantifying and rendering comparable and competitive every aspect of teaching and research. It pushes universities to invest money in things that get them higher rankings. It shapes the possibilities for me as a researcher, pushing me into writing more about the things that might have high impact in a way that can be measured, or high engagement, but only in a way that can be measured, and publishing more because that can certainly be measured. The relevant point here for our analysis is that data has both micro and macro impacts. The decision to center data impacts how people and organizations act and come to be. All of this is exacerbated by the pervasive myth that data is objective. As Rob Kitchen points out, data is often erroneously framed as being objective, neutral, and free of bias, as though it were simply natural and essential elements that are abstracted from the world in neutral and objective ways. If we think of data as neutral and free of bias, we can pretend that the decisions we make based on data are similarly neutral and free of bias. Of course, this is not the case. Data is never a natural representation. It is always collected for a specific purpose, making visible something that was previously concealed, and therefore constructing a new view about the world. As Lisa Gardelman and Virginia Jackson put it, data is never raw. It is always cooked, collected, stored, and circulated with particular aims and logics in mind. Data is something that is collected for a specific purpose, in making visible something that was previously concealed. What is measured and what isn't measured are mechanisms for constructing and forgetting knowledge. As Buckingham and Ferguson summarise, if a phenomenon isn't visible within a classification scheme, it is systematically erased. Similarly, the process of making sense of this data also casts how it is interpreted. I'm going to give you an example. Consider, for instance, the data collected about you through a learning management system, your clicks and your page views. When I click on your name in Canvas, I get this little rating: 1, 2, or 3 stars for your participation and page views in comparison to everyone else. A very basic and rudimentary piece of data. You might not know this, but Canvas logs everything you do when you're logged in. What you click on, how often you click on things, what time of day you use the site, how long you watch the videos, and when you stop watching them. I can download a spreadsheet with all of this data. I can even rank you. I can see who has the most page views and who has the least. Can you see how your knowledge of these metrics might shape your behavior? I can also see how this changes over semester. This is from my unit last semester, and you can infer things from this data, right? You can see how it takes time for people to get started, and then how people kind of slowly get a bit disengaged midway through semester. That's kind of cool data, right? Because I can use this knowledge to try and improve what's going on. Or have a think about, what is it that I'm doing in week 7 that makes people start to pick up interest again? Is it because of these topics, or is it because I'm talking about something really cool here? Or is it because there's an assignment deadline here? I can't remember. Blackboard's Data and Analytics website claims that this data can identify motivation and persistence to learn and help identify and overcome barriers to student success, while also optimizing student outcomes. Students with irregular and infrequent page views may, based on historical data of previous years, be categorized as at risk. But this creates a new view about this member of the student cohort. I can actually automatically email those of you who are in the bottom 10% or bottom 20% by these measures. This is the positive promise of this kind of technology. Maybe a student who might subsequently receive the support and motivation they require because the system, based on this data, has helped me identify a student who needs a bit more help. Yet, what about a student with caring responsibilities or no internet access at home? This student is inevitably going to have patterns of engagement that differ from the typical student. Categorizing this student as at risk is based on an often unacknowledged political claim about what good learning should look like. And the design of learning analytics systems that omit such realities are making a similarly political claim about what good educators should know and be considering in their teaching. Data-driven learning analytics inherently work to classify students, which can define how they are viewed by teachers and how students understand themselves as learners. The danger is, this student, who may learn efficiently, even if erratically, being classified as at risk, may affect how the teacher engages with them, demotivate the student, and encourage them to drop the class. If you were told that you were at risk, how might it affect how you learn? If I told you right before census date, would you maybe think you should drop the class? This is what I mean when we say that data is not neutral. We have internalized the idea that there is nothing more objective, more neutral, more informative, and more efficient than data. This is misleading. When an algorithm is fed data, a decision has already been made. Someone has already decided what data should be chosen and what data shouldn't be, what data is okay to leave out, and what data is necessary to include. And if data is, in reality, people, then some of us are being selected, while some of us are being silenced. Let's think about an example. Choosing data to train algorithms means making a choice about what data to include. Which individuals will inform the data set? the consequences of which can be profound and pervasive. Any sense of objectivity here is wholly illusory. To collect data, for instance, around victims of a particular crime, we would get far more accurate and higher figure by asking victims anonymously than by asking local police forces to report the figures voluntarily. This is because a lot of crime doesn't get reported, especially around things like domestic abuse. And what is reported may not give the true picture of crime occurrences in one area. This can then cause problems. If data is uncritically used to inform and decide the allocation of resources, and consider how the allocation of resources and policy decisions might shape how a local authority would respond to and support women who are suffering from abuse. In their book, Data Feminism, Catherine D'Ignazio and Lauren Klein discuss how there is a comprehensive data set at the US federal level of sexual assaults on college campuses. Colleges are required to report it. But whether students come forward to make these reports will depend on whether the college has a climate that will support survivors. Most colleges aren't doing enough, so we have vast underreporting of these crimes. Many of the colleges with higher reported rates of sexual assault were actually places where more institutional resources were already being devoted to support survivors. People felt comfortable coming forward. It's not that this data is evil or never useful, but that the numbers should never be allowed to speak for themselves, because they don't tell the whole story. They can't. They're just numbers. In Atlas of AI, Kate Crawford makes the point that the seeds of this data problem were planted in the 1980s, where it became common to use data sets without close knowledge of what was inside or concern for privacy. Data was treated as just a raw material under a logic of extraction, reused across thousands of projects. This has evolved into our modern day ideology of mass data extraction that powers big data. But data isn't raw, it is cooked. Data is extracted from a context and a politics. Sentences from Reddit will be different from those in children's books. Images from a mugshot database will have a different context and politics than those from an Oscars or movie red carpet. But they're still all used alike as a data set of photos, as a data set of sentences. Context, culture, and society are flattened out. So what gets measured and what gets left out when it comes to AI training data? This, I think, is one of the really interesting questions around AI. In the previous lecture, I discussed the workers who label data for AI training systems. These are typically workers in developing countries, working in countries like Kenya and the Philippines, or through platforms like Amazon's Mechanical Turk. We know very little about the workers of these platforms. AI companies pretend not to even use them. And so we know very little about what their biases might be. Sophie Bishop conducted research into YouTube's algorithm to see how it shaped content on the YouTube platform, what she refers to as YouTube's algorithmic political economy. The employed engineers who design and write the platform's algorithmic signals are the primary architects of content creators' visible cultural output. However, algorithms increasingly learn and self-sharpen, often causing unintended side effects and amplifying discrimination, refracting and sharpening class and gendered biases. Videos on YouTube can often be hidden behind restricted view, a filter offered by the platform that hides potentially offensive content. If your video is put on restricted view, it is less likely to be recommended to other viewers, and it can become demonetized. A vlogger, Rowan Ellis, demonstrated that the content that she had tagged or titled with LGBTQ keywords, including lesbian, gay, or LGBT, was hidden in restricted view. Safe Savage is the director of the Human-Computer Interaction Lab at West Virginia University, and she argued that this bias might come from the workers creating the training datasets for these algorithms, who are often working in a country where there is censoring of LGBTQ content. What they deem to be culturally sensitive or inappropriate shapes the very content that we see on YouTube. This data and its implementation are rendering some people invisible, which is why transparency about the data that is used in AI is so important. This kind of selection bias also happens in other ways. Google has a very large language model, which it uses for different natural language processing purposes. Their latest, biggest one, unveiled in January 2021, has 1.6 trillion parameters. This makes it the world's largest language model by some margin. Language models predict the likelihood of a sentence existing in the real world, such as, "I took my friend for dinner," would be much more likely than "I took my wall for dinner." The larger the dataset, the better the chances of AI-generated sentences being legible and appearing to be authored by a human. They created this dataset by scraping all the data Google has access to: websites, social media posts, emails, books, and so on. Really big data. Any page that contained any of the words on this list of dirty, naughty, obscene, and otherwise bad words was excluded. So this includes words like sex or gay sex, terms like twink or homoerotic or orgasm, even the words vagina, clitoris, and penis. Now we can obviously imagine contexts where these words are being used inappropriately or as insults, and we wouldn't want to train our algorithm on this. But what about a health website or an LGBTQ website? In a clear case of irony, even the website for Queer in AI, a non-profit organization campaigning against these types of issues, was excluded by this list. This means that the world's most sophisticated language model, which will form the basis for a wide variety of language applications, from Google Search, Voice Assistant, predictive text on your phone, render invisible certain cultures of languages that use these words. This is why we have to ask very critical questions about the data we interact with in our lives and the systems we encounter that are based on this data. Oz Keys points out that the solution to these shortcomings in data science are often problematically to expand the scope of data collection. Keys argues that, as currently constituted, data science is fundamentally the inhumane reduction of humanity down to what can be counted, and about using the view that this creates to control and standardize the paths our lives can take. And data science only responds to critique by expanding the degree to which it surveils us. What's the solution here? Should we tinker with what is measured? Add in accountability mechanisms? Can we reform these systems? Oz Keys argues no. Reform often benefits only the least marginalized, while legitimizing the system and giving cover for it to continue its violence. Making a measurement system more inclusive will not really reduce harm for the people actually harmed. This control and normalization is part of the point of making data science. It is required for data science's logics to work. The solution is instead to resist datification, resist this competitive market logic, the drive to compare and quantify and compete, and seek other ways of knowing and constructing knowledge that aren't reliant on the inherent reductive approach of data science. Another useful lens for this is Nick Couldry's and Ulysses Mejia's concept of data colonialism. They propose that the expansion of big data process is best understood through the history of colonialism. The new data relations we're experiencing in almost every aspect of our lives enact a new form of colonialism, normalizing the exploitation of human beings through data, just as historic colonialism appropriated territory and resources and ruled subjects for profit. The claim to absolute universality that is characteristic of European modernity is reproduced in data colonialism, and its logic of universal data extraction and management of human beings through data. This data colonialism paves the way for a new stage of capitalism whose outlines we only glimpse, the capitalization of all life without limits. Couldry and Mihijas point to the work of Peruvian sociologist Anibal Quijano in thinking about how we can resist this. To Quijano, the point was not merely to move past colonial thinking through the post-colonial, but to challenge fundamentally colonialism's legitimization through decolonial ways of thinking. Quijano focused on the legacy of historic colonialism, but his diagnosis is of enormous importance for addressing data colonialism too. What decolonial thinking in particular can help us grasp is that colonialism, whether in its historical or new form, can only be opposed effectively if it is attacked at its core, the underlying rationality that enables the continuing appropriation to seem natural, necessary, and somehow an enhancement of, not a violence to, human development. To quote from Quijano, outside the West, virtually in all known cultures, all systematic production of knowledge is associated with a perspective of totality. But in those cultures, the perspective of totality in knowledge includes the acknowledgement of heterogeneity of all reality, of the irreducible, contradictory character of the latter, of the legitimacy, the desirability of the diverse character of components of all reality, and therefore of the social. The better alternative idea of social totality, then, not only does not deny but depends on this historical diversity and heterogeneity of society, of every society. In other words, it not only does not deny, but it requires the idea of an other, diverse and different. Something that data science cannot engage with. In the same way that Quijano calls for an epistemological decolonization, resisting datification, quantification, metricization, and algorithmic control requires the acknowledgement of the heterogeneity of all reality, of the irreducible, contradictory character of the latter, of the legitimacy. Rejecting colonialism does not mean rejecting data collection and use in all of its forms, but it does mean rejecting the form of resource appropriation and accompanying social ordering that most contemporary big data practices represent. So in this lecture, we've covered 4 main topic areas. In part 1, we covered what is big data, the power that underpins AI. Datification is integrally connected to AI because datification makes AI possible, and it is AI and the fantasies that big tech have about AI and what it might do that are driving more and more datification of more aspects of our lives. The world's data volume has consequently increased dramatically in the past 20 years. In part 2, we discussed what is measured mattered. Metrics play an ordering role in the social world. What is measured matters. More than issues of surveillance, this is why big data is problematic. In part 3, I explained how data is not neutral. While often framed as being neutral or objective, data is not free of bias. Measurement constructs a view about the world. It is increasingly how we come to know things in biased ways. And in part 4, I emphasized how it matters what gets measured. When things get left out of measurement schemes, ignored or flattened, they are silenced. I hope you've enjoyed this lecture. Looking forward to discussing some of the ideas with you. Have a great week.